time to get ready for another lab, and so you're going to want to take some notes and pay some special attention to this video as we think about making some dilutions of some solutions. Here is the question you are going to answer in this lab. Can you find the solutions to correctly dilute the solutions to the concentrations that we're asking for? That's what your task is going to be. So, here is your challenge with a little more specificity. Who can make the most accurate dilutions? We are having a contest, and you are the contestants. You are going to be able to start with 250 milliliters of a solution. Now that's all you get is 250 milliliters of a 1.00 molar solution of red dye number 40. Now you're going to take that red dye number 40 and you're going to learn how to dilute it to make solutions with these concentrations. So you'll make 4 solutions. 1, 2, 3, 4. 4 solutions with these concentrations. 0.65 moles per liter, 0.55 moles per liter, 0.45 moles per liter, and 0.35 moles per liter. And these are the tools you get to use. You get to use a 250 milliliter volumetric flask, a 100 milliliter and a 10 milliliter graduated cylinder, a dropping pipette to help you carefully adjust volumes, and a 10 milliliter volumetric pipette and bulb, and some 250 milliliter beakers and a funnel. Now, how are we going to decide who the winner is? Well, you will bring a small sample of each of your final solutions. That's, the 1, 2, 3, 4. You will bring those up to an instrument called a colorimeter. And once you're at the colorimeter, you will put those samples into the colorimeter. And it only takes about 2 milliliters of the sample. You'll put those in a little container called a cuvette. You will record a reading on the colorimeter called absorbance, and you'll enter the absorbance into a spreadsheet for each solution. So, for each of those 4 solutions, you will measure an absorbance. Now, the absorbance is proportional to the concentration, so the more light that is absorbed by the solution, the greater the concentration. So we can determine the concentration from a we can determine the concentration from a calibrated absorbance versus concentration graph. And we've made one of those. That's already been determined. The spreadsheet will give you your percent error, and we'll be able to add those together and decide how you fared. Were you accurate with your measurements and your calculations? So the group with the lowest total percent error, as we add all of those percent errors together, wins. What's the prize, you ask? You will receive one of the following to be announced by your instructor: money, food, glory. There is a number of background items you will need to understand. You will need to understand how dilution concentrations and calculations work. We'll take a look at that. You will want to give some thought to how you are going to calculate the amount of stock solution needed to make another stock solution. So you're going to start out with this solution, and you're going to make this solution, and you're going to take this solution and make some of this solution, and you're just going to have to decide how you're going to do that. You're going to want to give some thought to the precision of the instruments made and to how you can use those to most accurately produce solutions of the correct concentration. and there are several measuring devices you can use, and we'll take a look at how to use each of those. You will need to give some thought to the dilution calculations, and so let's take a look at that right now. Well, we're going to look at examples of how to calculate the amount of stock solution needed to make another solution. It's a fairly simple calculation. We're going to look at 3 examples, and then you will want to make your stock solution calculations. Write those down so you'll be ready to start the lab. So here's our first question we're going to pose. For my 1 molar stock solution, make 250 milliliters of a 0.9 molar solution of red dye number 40. That means right here we are starting off with a stock solution of 1.0 moles per liter, and we just have that in a beaker of some kind. We're going to call this molarity number 1 because that's the molarity we are starting with. We're going to take a certain volume that we will call volume 1, and we'll transfer that volume to a volumetric flask. Once we have it in the volumetric flask, and of course since we're making 250 milliliters of solution, this is going to be a 250 milliliter flask. We're going to calculate V1. How much of this are we going to add to this flask? Once we have done that, we'll fill this up with water. How much water? Well, enough water to bring this to 250 milliliters of solution. That's the calibration line on the volumetric flask. And once we have done that, we will have our 0.9 molar solution of red dye number 40. Now, that means that here, how many milliliters are here? Well, we're going to call that V2. How many milliliters did we want for this final volume of our solution? 250 milliliters. And M2, we could think of this as solution number 2 that we're making. Solution number 2 that we're making here, we'd think of as M2 and V2. And we want the molarity to be 0.9 molars. Now, how does this equation actually work? Why does it work? Well, it works because of this. Remember, molarity has the units, moles, divided by liters of solution. Now, molarity, if it's moles divided by liters of solution, and we multiply that by volume in liters, you will notice that the result is simply moles. So in this equation, we actually have it work because the moles in condition 1 is equal to the moles in condition 2. We haven't removed or added any solute. All we have done is add water. And we've added water, so now we've diluted the solution to some lower concentration. We still have the same number of moles, but we've done that by increasing the volume and decreasing the molarity. So let's go on to actually calculate the solution to this problem. I'm going to go to the next slide, and on the next slide we're going to calculate this same problem. Now, just to review, we're going to use this equation. Molarity 1 times volume 1 equals molarity 2 times volume 2, where molarity 1 and volume 1 is referring to this more concentrated stock solution that we're starting with. And molarity 2 and volume 2 are referring to what we want to come out with in the end. What we really want to know is what is the volume that we're going to put into this volumetric flask right here. So we're going to solve this equation for V1. We know M1, that's the 1.0 moles per liter. That times V1 equals, we know what we want M2 to be, 0.90. That's what we want to come out with down here, 0.90 molar. And we know how much V2 is because V2 is the volume of our volumetric flask, 250 milliliters. So we want to solve this for V1. So V1 is going to equal 0.90 molar times 250 milliliters divided by 1.0 molar. And you'll see that yes, indeed, our units here work out, whether we use liters or milliliters. And we come out with 225. And our unit that we're left with is milliliters. So what does this mean? This means that V1, 225 milliliters, I am going to take, to make this solution, I am going to take 225 milliliters. I'm going to take 225 milliliters of my stock solution. I'm going to put that 225 milliliters of my stock solution, the 1.0 molar solution, into my volumetric flask. I'm then going to add water. How much water? Enough water to fill this up to my calibration line of 250 milliliters. And I will then have 250 milliliters of a 0.9 molar solution.